I am Vetri Chelvi. Good morning, students from Vetri and Vetri Neet Chemistry. Before going to the topic, one of the requests for the student, the viewers or the new to the channel, please subscribe my channel. Already it is containing some 80 number of videos for 2020 NEET preparation with a high content. Practice well. So my request is subscribe to give the energy for me to improve my channel. Now let us go to the topic today is optical isomerism. Okay, since this topic is very familiar with the children, straight away I am going to the questions. Okay, what is the condition for optical isomerism is the carbon should be asymmetric carbon. What is the meaning of asymmetric? Mean the carbon should contain with that 4 different groups. Okay, with that knowledge we are entering. Now what is the question is, which of the given alkane is optically active? You can see children, it is Aiims 96 and 2001. So let us see what are the things are given. You are provided with the 4 different alkanes which is optically active. That meaning is optically active means we have to find out which is having the chiral carbon. So which is having chiral carbon we have to find out. Let us draw the diagram for each one. For the A I am giving 3-methyl hexane. So what is hexane is you put 6 carbon atom. Next they ask you put 3-methyl. So now this is 3-methyl. Once finished mean you find out this is. Okay, what is here? This one 2 carbon. Here you see this is 2 carbon, this is 3 carbon, hydrogen, methyl. All the 4 are different. So this carbon is, what is this? This carbon is chiral carbon and this is the answer. Okay, even though we have identified, let us go and eliminate the remaining point. What is given is propane. Give the structure of propane. Okay, what is this remaining point? This is CH2. So this carbon is not chiral. We know because both are the similar group. Okay, now we are moving to the third option. What is it? 2, 3, 4 trimethyl pentane. Pentane you put 5 carbon. Okay, 2, 3, 4. Now let me write the numbering. 4, 5. 2, 3, 4 on the carbon. 2, 3, 4 you give the methyl group. Okay, and develop the remaining point. Terminal is the CH3. Here it is CH3. Now what else is here? Everything having 1 hydrogen atom. Let us see here. This carbon, these two are similar. This carbon, these two are similar. So they are not asymmetric. Now let us see this carbon. What about this chirality is? You take together. This is your, what is it called? The total number is 2. Okay, here you mark it. This is your total is 2. That means what? Both groups are same. So this compound also not having chiral carbon. What is this one? So this is I have written for B. This is written for C. This is written for A. So now let us go to the D option. Let us draw the diagram for D. What is given is 2-methyl butane. Write the butane is with 4 carbon. 2-methyl this is. Now the structure is, even you need not complete. These are the both are similar group. So this carbon is not asymmetric. Definitely the remaining carbons are not asymmetric. So what is this is? Our option is A. So whichever compound is having the asymmetric carbon, or we can call it as a chiral carbon, it is optically active. Like that you have to approach the question. Now let us go to the same type of the question, Aiims 2002. You following next year itself you are getting. Which of the given is the chiral compound? The same thing. We want a chirality mean you take it, knowledge is very simple. You approach with this word asymmetry. Why I am insisting is because this is indicate they are not same. So that you take it as a asymmetry. One S is you cancel it. Okay children, so in chiral, instead of chiral, you take the immediate word of this. Now go to the each structure. hexane. Draw the hexane, which is 6 carbon atom. That's all. There is no other things are there. So what is the meaning of it? Everything CH2, 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 CH2. There is no, what is it called? It as an asymmetric carbon. N-butane. Everything normal mean it is not having. Without doing, we can find out. Anyhow, for teaching, I am going for the B option, which is N-butane. 1, 2, 3, 4. Normal butane. Okay. Now this is. Here it is having, this is 2 hydrogens similar, 2 hydrogens are similar, these two are not correct. Okay, so this is also not asymmetric. Now let us go. Methane is 1 carbon with 4 hydrogen. Methane formula we know 4 hydrogens are similar, so not asymmetric. One and only option is D. Let us go and draw it. Trimethylhexane. You see hexane is 6 carbon. You draw 6 carbon. It is 6 carbon. Okay, now 2, 3, 4 number is 1, 2, 3, 4, 5, 6. 2, 3, 4. 2, 3, 4. You give, it is given as a methyl group. And what is in here? It should be having the hydrogen. Now structure is ready. Now how it is answering for the, what is it called? This is the CH2 and this is the CH3. How it is optically respond mean? This carbon may not have because both are similar methyl group. So this is not asymmetric. Here what about this one? This carbon I am selecting as a asymmetric carbon. This carbon is asymmetric. How you can find out is, this is attached with 1 hydrogen, 1 methyl and a third valency with this. Is how many total carbon we take the chain? It is 2 carbon. That is 2 number of carbon. Here you can find a total chain is having 3 carbon. So one side is 2, that is called, it may be a substitute of ethyl. Here it is 3 substitute of propyl. So all the 4 groups are different. One is hydrogen, one is methyl, another is 2, another is 3. So this carbon is asymmetric. That meaning it is answering for your optical activity. So my answer is 2. That is called it as a not 2. This is the D. So this is the way you have to approach children. Knowledge is very simple. Anyhow, you draw and find out which of the given acids does not exhibit optical isomerism. So you are provided with lactic acid, tartaric acid, militic acid, alpha amino acid. Which are not showing. We know by knowledge lactic acid is answering, tartaric acid is, and we know this is, so by knowledge we can eliminate. Okay, even though you know, for your knowledge I am giving diagram of lactic acid is. What is lactic acid is, this is, what is this one? You call it as a 1, 2, 3. 2-hydroxy propanoic acid, this carbon is. This carbon is asymmetric carbon. Lactic acid A. It is answering. There is attached with 4 different groups. Now I am giving diagram of B. What is B is called as a tartaric acid. We can take the structure of your tartaric acid. This is your tartaric acid. Draw it H, OH and OHH. Anywhere you can draw it. Now these 2 carbon atoms are asymmetric, which is attached with the H, OH, CO different group. This is tartaric acid, answering. Next one is called it as a militic acid. What is militic acid is this one, carbon double bond carbon with the cis isomer. That is hydrogen here, it is hydrogen, COOH and COH. This is where militic acid. You can see here the carbon, no carbon is having asymmetric. Very important, the carbon considered should be the sp3 hybridization. These 2 carbons are not sp3 hybridization. So it is not under the topic of optical isomerism. It is geometrical isomerism with fumaric acid. So this is does not exhibit optical isomerism. So this is my answer. This is the structure of militic acid. Now we are moving to the last one is called the alpha amino acid, where student may not know the structure. Like alpha amino acid mean, what is the alpha amino acid mean? One valency with the amine group, another valency with the acid group. This is in the topic of biomolecule. This is the amino acid and this is your alpha amino acid. That meaning what? This carbon is asymmetric. So this is having 4 different. So it is also optical. Asymmetric, asymmetric, asymmetric. All the 3 answering. Militic acid is not answering. So we are moving to the next question. The 2 possible stereo structures of this structure which are optically active or call it as this is a Neet question 2015. 2 possible stereoisomers of the compound is given. Let me write first the compound. What is this is you are always write the highly oxidized state at the top and the next following and the bottommost is here. Okay, this is nothing but here by observing 1, 2, 3. What is it? 2-hydroxy propanoic acid is nothing but the lactic acid. Just now only I told. So for this, which are optically active or called, they are giving. So let us, for the lactic acid, I am going to give the D isomer and L isomer. Let me expand and write. This is COH, CH3, HOH. This is one format and this is your mirror and there I am putting the mirror image COH and CH3. You bring OH here and H here. So this is I am labeling LD mean this is I am labeling. Yes, both are non-superimposable mirror image. That is you take it and fix it here. What is having? OH is lying on H and H is. So this is called not superimposable mirror image. Superimposable mirror image. So they are giving non-superimposable mirror image. That is called it as a, what is it called? Enantiomers. So now not a mesomers, not diastereomers. So this is where well clear knowledge. Object mirror images are non-superimposable. By definition, it is called it as a enantiomers. So very simple knowledge, very interesting question. Continuation of optical isomerism. I will do it in the next video also. Thank you children.